In this homework, we will be mainly focused on the integration by parts. So let's recall the formula. Integration by part, the formula would be integral v du is equals to uv minus integral of v du. So the most important part is choosing u and dv. Now let's take a look at some homework problem and try to work with it. So number 1, we have integral of 12x ln of x dx. We need to pick our u and the dv. So I will pick, because later we need to integrate the v, and then so we need to be careful which one is easier for us to integrate. So if I let me use a blue one. This guy equals to our u, so our v dv is going to equals to 12x times dx. So this is what we're going to do. U is equals to ln of x, then our dv is going to equals to 12x at dx. Then we're going to differentiate u and integrate dv. So our du is equals to 1 over x times dx. Then we want to find the integral dv, which is this part is equals to 12x dx. Then this is equals to 6x squared. So that gives me a v. So v is equals to 6x squared. Because this part, antiderivative and derivative, they cross cancel each other. Just like you multiply and then divide, you will get the original function. To cancel addition, you need to use a subtraction. So to cancel a derivative, we need an integral. So that's why we integral on both sides so that we can get a single v. Okay, so the next step is we want to apply the integration by parts formula. So the formula is on the top in the red, which is equals to, I'm going to write it in red, uv minus integration v du. Now let's substitute that into it. So u is equals to ln of x times our v is 6x squared, and then minus the integral of v at du. So our v is equals to 6x squared, and du is equal to what? Du is equal to this part, 1 over x dx. So you need to be very careful about your step. So these 4 part or 5 part is help you to do the substitution later. So you should write it next to your solution. So later it's easier for you to find whatever that you need to plug it into the formula. All right, so let's clean up a little bit. So this part is going to equals to ln of x times 6x. Now we need to integrate this. Well, at least one x got cancelled. I have integral 6x dx. These shouldn't be hard because antiderivative or integrate of 6x at dx is going to equal to 3x squared. We still need to plus a constant. So here is the final answer. Would be ln of x times 6x squared minus 3x squared plus c. Okay, now let me show you another example. Number 2. Integrate x times e to the negative x at dx. This is also we need to use the integration by parts. So the first step is we need to choose our u and dv. So in this case, I'm going to let u equals to x, and then our dv equals to e to the negative x dx. Okay, then we differentiate the du. So du equals to dx. And then we integrate the dv so that we can get the single v. So we get the integration on both sides, the integrate on both sides, e to the x at dx. All right, so our v is equals to e to the negative x. So that's it. So the next part is we apply the integration by parts of formula. And I'm going to write the formula here again. This is equal to uv minus integrate v du. All right, so our u is equal to x, v is equal to negative e to the e to the negative x, and then minus the v integral of v is equal to negative e to the negative x, u is equal to dx. All right, so after we substitute that into our formula, we got this guy. Okay, it looks very complicated, but we can simplify this to negative x e to the negative x, and then plus e to the negative x dx. So that looks nicer. Now we want to integrate this part, which is, we did it earlier, in here when we're doing the differentiate, this part. So we will get negative e to the negative x. And then don't forget to plus c. So here's the answer, but you can also simplify it because they both have a common factor e to the negative x. So you can also pull this out. Then you have negative x minus 1 and then plus c. Either one is considered correct for number 2. All right. Now, next one, number 3. Number 3, I have x to the 4th ln of x dx. So similarly, we use the integration by part. We need to find our u and dv. So in here, I will let u equals to ln of x. So dv is equal to the rest, which is 4x times dx. So the next part is we integrate it or get the differentiated. So differentiate first. So I have a du equals to x squared du is equal to, 1 over x and dx. And then now we need to find u by doing the integral on both sides. When we do an integral on both sides with the integral dv equals to integral x to the 4th dx. So now we need to find the antiderivative of x to the 4th, which is 1/5 x to the 5th power. Okay, now we want to substitute into the formula. So u is ln of x, v is 1 over 1/5 x to the 5th power, and then integrate v, which is 1/5 x to the 5th power times 1 over x dx. Now we want to clean this up a little bit because it looks very messy to me. I would do x to the 5th over 5 ln of x. We can pull the 1/5 out. Then I will get 1/5 x to the 4th and then dx. Now continue to do the integration. Oh, this is subtraction. When we're subtracting this, we should get s to the 5th, which is we did it earlier. Oh, no more dx, but adding a constant at the end. Okay, so simplify it and clean up the answer. You have this for number 3. Okay, number 5. Do we have number 4? Number 5, we can do number 5. Number 5, number 5 is a little bit harder, but again, this is all the practice of use substitution and integrate by parts. So let's do number 5 together. So number 5 is from 0 to 1, e to the 3x, and then x dx. So the first step is I want to let u equals to x, and then dv is equals to 1 over e to the 3x dx. And then differentiate u, we have du equals to dx. That part is easy. So now it's antiderivative of the v. So this part we need to use the use substitution, which is we can let e to the negative 3x. Let me write this as e to the negative 3x. So I can use u substitution. U is equals to negative 3x. So that means we integrate e to the u dx, and we still need to solve for dx. So let's find du on both sides. So I have du dx is equals to negative 3. So that our dx is equals to du over negative 3. So we can substitute that into our dx. So here I have a du over negative 3. So after simplify, I have 1/3 e to the u. And then we can substitute the u back, which is give me negative 1/3 e to the negative 3x. So in fact, this is going to be our v. Then we finish finding our v. Okay, now integration by parts. So I have a uv minus integrate v du. So u is equals to x, v is equals to negative 1/3 e to the 3x, and then minus integrate v, which is negative 1/3 e to the negative 3x, and then du, which is happen to be dx. So here we need to use a u substitution again. But if you simplify it, let me simplify it, write it nicely, x over 3 e to the negative 3x, and then plus 1/3 integral e to the negative 3x dx. These part actually, when we're doing the integral by part, the substitution, we already did it. This part is the same as this part. So that means here is our answer, so we don't need to do the calculation again. So you don't need to do it again, but of course you can do it again to check your answer, see if this is correct. Plus 1/3 times negative 1/3 e to the negative 3x. So simplify it. Again, I want to clean this up a little bit before we find the defined integral, because at the end, all of this, after we're done, this should be a fine line from 0 to 1, from 0 to 1. But before we're doing this, I want to clean up the answer a little bit. So first thing that I can clean up is they both have a common factor, e to the negative to the 1/3 power. So I can have e to the negative 3x power, not 1/3, 3x power, and then I have negative x over 3 minus 1/9. And then from 1 to give me 1 second. From 0 to 1. So now we can do order substitution. It should be easy because all we're dealing with is just substitute 0 and 1. So let's do the 1 first. So e to the negative 3 times 1, and then negative 1/3 1 minus the whole thing, e to the negative 3 times 0 times negative 0, 3 minus 1/9. Okay, so I have e negative 3 times this part from the common factor, which is negative 4 minus e to the 0 power, everything is going to equal to 1. So whatever inside the parenthesis is going to be 0 minus 1/9. Oops. Simplify, I have e to the 3rd times negative 4/9 minus a/9. That would be my final answer. I made a tiny mistake in here. Is 1 times this step should be inside the parentheses, should be 1 times negative 1/8, 1/9, sorry. So this should just be positive 1/9. So that would be the final answer, but you can clean this up a little bit to look nicer. So since they have a common factor 1/9, I can pull this out. Then I have a 1 minus 4 times e to the 3rd power. So that should be the final answer. All right, next one, let's go over number 7. Number 7, we have integral from 1 to 3, ln of 2x plus 5 dx. And this one, although we learned integration by parts, but this one is very hard because not two functions multiply together. So we don't necessarily always, because we learn integration by part, we always use integration by part in this homework. In fact, this one we're going to use substitution. So u substitution. So we net u equals to 2x plus 5. So in this case, du dx is equals to 2. So our dx is equals to du over 2. So now let's substitute the things. So I have ln u dx is equals to du over 2. So I can pull the 2 out. All right, so ln x, the dx from the class note, this is something that we learned during the class, so you can check your class note. this part. This part, I forgot the u. In this part, when we're trying to find the integration, ln u du, we need to use integration by parts. So to do that, we can I'm going to skip the step since we already talked about that during the class. I'm going to show you how do I get the integral ln u du. So what we're going to do is going to let u equals to x, and then I will get ln of u minus u times 1 over u at du. Simplify, I have a ln of u, and then minus integration of 1. So this gives me a u. So this is from the class note. This is a quick recall. Please go back to check your class note if you forget. All right. So now I get 1/2 from u times ln of u minus u from 1 to 3. And our u is equal to 2x plus 5. Now we can substitute this back. I have 2x plus 5 times ln 2x plus 5 minus 2x plus 5. Don't forget the parentheses, because you see that here we have a subtraction. If there's a subtraction, it's going to change the sign inside the parentheses. So since we are subtracting the whole u, our u is 2x minus 5. So that means you want to put the parentheses just in case you forget about that. Simplify it. I have sorry, there's some glitch for my iPad. Let's continue for the substitution this back. So at the end, your results should be ln of 11 times 11 minus 11, and then ln 7 times 7 plus 7. And then you merge the like terms. So clean this up a little bit. Times 11 minus 11 plus 11 gives you minus 4 minus 7 times ln of 7. And 1/2. So I can either write it as 11 times 11 half ln of 11 minus 2 minus 7 over 2 ln of 7. So that would be final answer for number 7. Okay, number 10. Number 10, I have integral from 1 to 2 ln of x over x squared dx. So this one, we need to use different integration by parts. So u equals to ln of x. So our du dx is going to equal to 1 over x. Now we solve for du. Du is equals to 1 over x times dx. Next one is dv. So the rest of it is equal to dv, which is 1 over x squared dx. We can write this as a exponential form, and now we get the integrate on both sides. Then we got v equals to negative 1 over x. Now replace it. It's equals to uv minus integrate v at dx. Dv, du. That's the formula. Our u is equals to ln of x. V is in here negative 1 over x. we can integrate this part first, which is this part is from 1 to 2, and then subtract. Integrate v. V is negative 1 over x. Okay, this is a little bit cramped. And then du is 1 over x at dx from 1 to 2. So we can integrate the first term, which is the left term. I have ln of 2 times negative 1/2 minus ln of 1 times negative 1 over 1 minus the integration. We can do it later. All right. ln of 2 is just a constant, so you don't need to really solve it. And ln of 1 is always equals to 0. So now let's take a look. So this one is equals to negative 1/2 ln of 2 minus this part, because this part is equal to 0. So that means this whole term 0 multiply everything equals to 0. So basically it's minus 0. Now we can do the integration of negative. Let me clean this up a little bit. We can pull out the negative sign, so this has become addition, x negative 2 dx. Okay, now we need to find the integration about x minus 2, which is, we also did it earlier in here, which is equals to negative 1 over x. So this is negative 1 over x from 1 to 2. So I have a negative 2 minus negative 1 over 1. Simplify all of it. So this will become plus 1. I have a negative ln of 2 over 2 and then plus 1/2. So that's it. That's for the number 10. Now I want you to do number 11 by yourself and number 13. So I can give you the final answer for number 11. It's going to equal to negative 1/4 ln absolute value x minus 2 x plus 2 plus c. I want you to practice by yourself. This is going to use integral by parts. And then next one is number 13 is 4 plus x squared, square root of it, and then dx. This one you need to use the integral table to solve it. So that's it for homework 3.5. Let me know if you have any other questions.